Hi, everyone. Thanks for joining us for another episode of Deep Random Talks. Today, with us, we have Sam and Amar, and we are going to talk about tools for thinking, human computer interfaces, and it's mandatory these days to talk about large language models, so we do a bit of that as well. So, thanks for being with us, Sam. Thanks for coming back to the show, Amar. Um, I recently started listening to a podcast called Tools for Thinking, run by BetaWorks, which is which is an investor in based in New York City, I believe. And they invest in tools for thinking, and they were talking to Sam and another person, and I really liked what I heard on the show. So I was just messaging Sam on LinkedIn saying, well, we should definitely talk. So here we are. Thanks for accepting to come to our show.
My pleasure.
But to give our audience a sense of who Sam is, Amar is going to ask a few icebreaker questions. So let's start there.
Okay. Sam has a very big intro, but let's start simple. Where are you located these days, Sam?
So I am located in Kansas City, in the Kansas City
Okay.
metropolitan area. Yeah,
And is that what you call home as well?
yeah. This is where we live.
Beautiful. And uh, I did want to ask how you introduce yourself at dinner parties.
That's a good question. I guess it kind of depends the group or the situation. And sometimes I'll say I work for a venture capital firm, so Lux Capital, where I work. Sometimes I'll say I'm a writer because I've written several books and I do a lot of other popular writing. Depending on how detailed I can go, I can kind of explain my role of like scientist in residence at Lux Capital and kind of how I explore the landscape of science and technology. But it really depends on the specific audience.
Yes. Scientist in resonance was a very cool word. I remember when Amir first brought it up, he was like, "That's the job I want to do when I grow up." How does someone become a scientist in residence?
I guess you have kind of a very circuitous path in terms of like your career. I mean, so I'm trained as a scientist. I have a PhD in computational biology. I got my start in um, computer science and biology, and especially in kind of like evolutionary modeling, kind of like modeling genetic change and things like that. Although the truth is, I was also part of this like interdisciplinary fellowship program around complexity science and like nonlinear dynamical systems and networks and how they interact and like big complex systems with huge numbers of interacting parts. And it connected areas in biology, and it brought in like physicists and sociologists and all these different areas. And I thought this is actually the thing that I want to get more into. And so I kind of moved into this very interdisciplinary space. Did a PhD and then a postdoc in kind of this area. Actually spent my postdoc doing more around like understanding, like using math and computer models to understand scientific and technological change. And then after the postdoc, instead of kind of continuing the traditional academic path, I actually then moved into the foundation world. So by this point, I was already I was doing all this weird research, but I was also beginning to write for general audiences as well. This is one thing that I find very gratifying. So I was writing for newspapers and magazines. I was actually working on my first book about how what we know changes over time. I joined the Kauffman Foundation, which is a big philanthropic foundation devoted to entrepreneurship, innovation, education. And they were building this like in-house think tank, basically. It's kind of like in-house research capacity. Joined them with another kind of weird title as a senior scholar. Kind of spent some time working there, and then now about I guess like 7.5 years ago or so, I joined Lux. And so Lux, I mean, we're an investment firm based in New York City in the Bay Area. So I'm working remotely. I've been working remotely for a long time. We invest in, and people talk about like deep tech or emerging tech or frontier tech. I would say another way to describe the kind of things that we think about are things that feel like science fiction. That's that's the area that we play in. So everything from like AI, robotics, outer space, biology, kind of the intersection of all these different areas. That's kind of the things we think about. And so my role as scientist in residence is basically to survey the landscape of science and technology and find areas and individuals and communities that we should be involved with, and then bring them into the orbit of Lux. And sometimes based on that, and source deals and find companies we might want to invest in, or find people we might want to build companies around. Some of it's connecting those areas and those ideas to our portfolio of companies we've already invested in, but a lot of it's just like engaging with the public through writing and speaking and kind of connecting interesting people and ideas into the orbit of Lux, so that maybe down the line these are going to be the kind of things that will be relevant for investment. And so for me, the fact that I've kind of been interested in many different scientific fields, and so I've played in biology, I've played in quantitative social science, I have spent a lot of time thinking about the nature of scientific and technological change. And rather than that kind of being a bad thing, in many ways it's kind of like it's actually a good thing when it comes to kind of working for a venture firm and thinking about the entire landscape of science and tech, because I've had the opportunity to play with all these different areas and write about them. And so it's so I feel very fortunate that I'm able to kind of leverage kind of my weird background and interests in a very positive way.
Beautiful introduction.
Sometimes I have done a bit of that nonlinear career path as well, but also I have moved around geographically quite a bit. I grew up in Iran, then moved to Canada, then moved to England, then came back to Canada. Now I'm between Canada and the States. Very soon I'll probably move to. And one of the things that I've noticed from both the academic nonlinear, sorry, the professional nonlinear path, and also where you live in terms of culture, is that every time that you do a nonlinear move like that, it results in you dropping a lot of the things that were not that important to believe in or know, into things that are new and exciting and can learn them, and it just changes how you think about world around you and how you carry yourself, and the things that you hold true and dear become very different, and that don't. I completely understand probably what Amar was saying earlier about you are the person that I want to be when I grow up. Makes a lot more sense to me now that I hear this part of your story. But
Yeah,
we
actually,
want to talk about.
I was just going to say, it reminds me when you were saying of like either moving fields or moving like actually like geographically, it reminds me a little bit of kind of like the algorithm of like simulated annealing, where you kind of like you are occasionally you're kind of like trying to get more and more optimized, but then you kind of need this shock to the system, and then that kind of allows you to kind of get into some different part of some sort of optimization space, and and realizing kind of okay, what are the things that are actually important. So at a very high level and kind of hand wavy way, I feel like there's some interesting things there in terms of helping. These kind of shocks actually are very helpful for like figuring out the different things you want to do.
100%. So we are going to talk about human computer interface and how machines enhance our ability to think. And when we were doing the coordination call, you said very early on in your younger years, you got exposed to sci-fi and you were very excited about all of these amazing things that people were doing in these movies and stories. And you had exposure to computers actually fairly early on and started trying to build games and other types of things. And HyperCard was something that you mentioned in the podcast with Jerry. That was very interesting for me. I wasn't familiar with it, but when we were doing the coordination call, you mentioned that as well. So maybe take us back. We want to talk about human computer interaction, but what formed your early opinions around how people can interact with computers?
No, this is great. Yeah, so I'll kind of take that. And the truth is, both like the science fiction and kind of early exposure to computers are all kind of bound up. I'll try to kind of do them in order, but it'll probably end up like weaving back and forth. But yeah, so in terms of like my exposure to science fiction, I I was a big fan of science fiction. I actually my father grew up with the original Star Trek series, and so when the Next Generation, like the next series, came out, I think I was in kindergarten at the time, and my father had like my brother and I watch it, and we were really into it, and so I was exposed from a very young age both science fiction, like these TV shows, but also I read huge amounts of science fiction, like kind of like golden age science fiction of like Isaac Asimov and people like that, as well as kind of more modern stuff. My grandfather, he was also a very big fan of science fiction. He actually, and he read science fiction probably since like the modern dawn of the genre, and so he read, I think, Dune when it was like serialized in a magazine before it had even become a book. And so and my father, like they both really worked to kind of expose me to these ideas. And for me, it was a really like science fiction is, I would say, I mean, there's many great aspects of it, but for me, it was also like people who were able to kind of articulate this like very clear vision of the future, and especially like the Star Trek vision of the future is a very positive vision of the future. Of kind of seeing kind of people who are like working together. There's like post scarcity. There's all these wonderful things, but a lot of science fiction is also saying, rather than just kind of saying, okay, here's a cool new gadget, saying let's figure out what like when this gadget or new technology is like deeply embedded in society, what does it mean? How does society change? Like how do we kind of understand these like second order, third order effects, kind of all the different knock on effects, like really understanding what it means to kind of think holistically about like the societal, regulatory, legal, all these kind of like different aspects of technological change. So for me, I found that incredibly exciting to kind of just like think, like be guided by these writers and these creators who are kind of like helping think through what the world would be like when artificial intelligent agents are omnipresent, or what it would be like to have an android and like data on Star Trek, for example. I mean, like, there's actually even an app, like one of the episodes from the first few seasons is whether I think there's some scientist he wants to actually like basically study data and kind of like break them down, and like they have this argument of like whether, and it actually goes to a court case, like is he actually like does he have rights, and like how to think about these kinds of things. And it was enormously valuable and kind of like eye-opening to see that kind of thing. And alongside of my exposure to science fiction, I was also being exposed to computers. And so my father, he was a very early adopter of computers, and so our first computer that we had as a family was the Commodore VIC-20, which I think like William Shatner, going back to the Star Trek connection, he was actually the pitch man for it, and he would like, you can find old advertisements on YouTube of like he's talking about it. It's like the Commodore VIC-20 is like the wonder computer of the 1980s. I think it was eclipsed by the Commodore 64, but the Commodore VIC-20, I mean, to give you a sense of like how it operated. So there was no screen. You connected it to there was no monitor. You actually connected it to a television, and the external drive was this like the Commodore data set, which was basically a cassette player. Like you had like these things that look like audio cassettes. You put them in, and it was recording it on this like magnetic tape. And so the entire computer itself was, you had this like external data set, then you connected to the television, and the computer was this just like thick keyboard that had the machine inside it, with a very small amount of RAM, and like it was just like basically just a keyboard interface. And for me, so I was very little when we first got this computer. I was probably 3 or 4, and so I didn't know how to program at that time. But because a lot of programming was not like, you didn't just buy programs, and you could buy like the cassette tape, but often one of the things you do is you would just actually program it yourself. And so you would buy a magazine that had these things called type-ins, and you would like, it would be like code in the magazine or in the back of the magazine, and you would just like manually enter it in. And so for me, some of my first experiences of programming and understanding computing were watching my father type in like laboriously like these entire programs. And I could see the very clear relationship between the text that was being typed and the results on the machine, like results on the screen. Sometimes it would work well. More often than not, there would be like these crazy bugs. So I have this vague memory of like, it was like some like downhill skiing program, and it didn't work. My dad like entered some error, and so like there was like a whole bunch of like garbled, glitchy stuff on one side of the screen. And for me, that was actually really interesting to kind of see the fact that like when you messed up some of this type, like some of the text, it actually had this very real effect. But within a few years, though, my family moved to Macintosh, and so the first Mac came out in 1984. We got, I think, our Mac probably like the late 80s, like a few years after that. And so for me, like, I would say, going back to like the kind of the human computer interaction, like, the Macintosh had just this like enormously different feel to it. And obviously, just the form factor was different. It was like this like hermetically sealed, like little kind of like box. It was like with an oscilloscope size screen. But the fact that like you could use a mouse, and there were the windows, and like the whole like kind of like ideas that kind of came out of Xerox PARC, like these things were, they just changed the way in which you interacted. But for me, one of the most powerful, I guess, most powerful experiences with kind of my use of the early Macintosh was this program HyperCard that you mentioned. And so HyperCard For those who are not familiar with it, and it's basically it was this authoring system for people to kind of build. I guess the way to describe it best is almost like your own website that is housed locally on your computer or on a disk. And so the way it was, you would create cards, and each card would be a screen, and you could put buttons and text and things like that. And with the and then the cards would kind of level up to like a stack. So you would have like lots of individual cards, and then they would kind of go together into a stack. And you could just kind of put things on it. So like, let's say you wanted to like store a whole bunch of recipes. That was super easy. You could just type a whole bunch of recipes on there and have different cards for different recipes. But you could also add buttons that would then allow you to do different things. And so like you could easily make a button that you click on the button, it goes to the next card, or click on a button and makes some weird noise. But then underneath the hood, you would then also be able to actually program things yourself. Like there was like an entire programming language called HyperTalk that was kind of like human-like in its kind of programming affordances. But it was also very powerful. And so ultimately, HyperCard was kind of the first taste of what I then learned later was, I guess there's a phrase like Seymour Papert, kind of he was one of the creators of the programming language Logo. He talked about low floors and high ceilings, the idea that it was very easy to kind of have this on-ramp to using this tool. So it had a low floor, but it had a very high ceiling. There was a huge amount of open-endedness in terms of what could be done. And so I loved HyperCard. Probably my first computer program was actually built using HyperCard, where I think I built some sort of like password generator program, and you could have like you could create like different ways in which you want to make it could just be like a totally random password. It could also be one that maybe is a little bit more human pronounceable, which of course is now I found in every sort of like password generator program. Not due to me. I don't think I had anything to do with that. But it was great. It was like a very exciting thing. And then for me, and then I was able to kind of use that and then begin after I kind of got comfortable with HyperCard, then use it for lots of other different use it for other things, and then from there kind of had the comfort to then use other kind of programming languages and programming environments. But I would say the certainly like the science fiction lens of like, okay, what can we do with computers and technology? That definitely informed the way in which I thought about actual computers and use them. And so I can go into more about this as well. But yeah, it was. But I would say those two things intertwined gave me this kind of like very heady sense of like, okay, really, what is possible, and like this open-endedness of machines, and it was super exciting.
If I can recap that, the main problem that got you excited was the ripple effects of newer or science fiction level deep tech, and exposure really came from a lot of the early science fiction that were coming on, and early computer technologies that you had a chance to experience firsthand. Um, in that context, like once you were through that phase and started to more seriously think about that problem, or the first question then becomes, when did you start to more seriously think about that problem, and what were the early days of that like?
For myself, the early days
Yeah.
for myself, like yeah, and so I would say, and yeah, so I've been thinking a lot about and these kind of like science fiction, like visions of the future, and like what we can
Mhm.
think about in future science and technology. And I was obviously like enamored of computers, and I began kind of programming lots of different things. I would say, I mean, I played with a lot of these things, and certainly they were hobbies for a long time. But
Mhm.
probably one of the time when I began to kind of think about it in terms of like the in terms of the context of like how like these tools that can kind of like change how we think about the world, or tools that can kind of allow us to, I mean, whether it's like democratizing computation, like HyperCard, or even just kind of like think more broadly about this. Actually, kind of going back to like my science training was as I began doing a lot of work in complexity science. And one of the key ideas in kind of complex systems is this idea of like the network. So you kind of have like you can whatever system you're looking at, you can often abstract away all the details and create these networks of nodes that are that are connected by edges. So it could be
Mhm.
you could have a social network, so individuals who are friends with each other, and so you kind of have nodes of humans and connections of friendships. But it could also be it could be a biological network. So you have nodes that are proteins, and any protein that actually interacts within a cell receives an edge. And so you can kind of structure. You can study that. You can do technological networks. You can look at the computers within the internet, or you could look at modules within software and how they interact. And so the truth is, though, underlying all of this, there is this sense of, okay, there is a network. It might be a changing network over time, but there's kind of this structure of interaction. And coupled with that was me. So there's the network component, and then there's also the fact that I was beginning to do more research about kind of understanding scientific and technological change and looking at how people create new discoveries and create new ideas, and alongside this, realizing that oftentimes the where the ideas are being created are essentially it's someone creating connections between nodes that had not been connected before. And so there's kind of this like combinatorial aspect of new thinking or new ideas and new construction. And the truth is, I'm not far and away I'm not the first person to think about this kind of thing. And in fact, actually, so if you go back to like the mid 1980s, there's this classic paper by the information scientist called by the name of Don Swanson, and the idea, and so the paper is called undiscovered public knowledge. And the idea behind this is he says, okay, like, I'm going to do a thought experiment. Imagine somewhere in the scientific literature, there's a paper that says A implies B. And then somewhere else in the vast scientific literature, there's another paper that says B implies C. It might be in the same subset. It might be in like a different subfield. It might be in a totally different field somewhere else. But because of the massive size of the scientific literature, no one has ever actually read either like these two papers together. And so even though it might be true that A implies C by combining these papers, no one knows this. And so there's this undiscovered public knowledge. And so Swanson, he was actually not content leaving this as a thought experiment. He decided he was actually going to see if this was true and if he could actually make discoveries. And so he was using kind of the cutting edge technology at the time, which was basically like keyword searches within like online databases. But he actually ended up making discoveries and was actually able to, I think, publish certain discoveries in medical journals, even though he was not a physician. He was not a biomedical scientist. And so I think one of them was he discovered that there was a relationship between like consuming fish oil and actually helping treat the symptoms of some sort of circulatory disorder. And so, and the truth is, since then, there's been a huge number of people who've begun thinking about, okay, if we view knowledge as this semantic web or whatever it is, can we actually create tools to kind of help us stitch together knowledge that's in there, whether it's like the cutting edge of like new papers that are happening, whether it's finding things within kind of the archives of old technology or old papers. And I was fascinated by this. And so kind of through reading this and kind of thinking about complexity science and kind of the regularities of knowledge, this kind of all led to kind of my first book, kind of The Half-Life of Facts, which is about the regularities behind how what we know changes over time. But it began getting me to think about, okay, what are the kinds of tools that we can kind of build to kind of help accelerate these kinds of ideas and these kinds of things?
So I just wanted to bring up the book that you wrote, and I'm glad
Yeah,
that
sure. Yeah.
you created a segue. So you have a book called Half-Life of Facts. And what you've been talking about just now is all around the fact that facts exist in our literature, in our documents, in our heads, and these facts have very complex relationships to each other. Like some of them caused other ones, some of them are just correlated with each other, etc., etc. So there is this very complex web of knowledge that exists in our heads and in our artifacts that we have created over time. And, it is not completely crazy to think that if we had a good enough system to keep track of all of this and allow us to see connections that we haven't made previously, there could be a lot of interesting things to discover. And creativity and discovery doesn't need to be this genius thing that happens only when you're taking a bath, but rather, a thing that can be systematically done. And one of the things that is very interesting for me about your book is that your book is probably the most relevant book to read in the past 3 months, because we went from, only nerds know about language models to my aunt talking about language models, right? So, and that rate of change is drastic, is explosive, is unlike anything that we have seen before. So, given that in the book you're talking about, facts that change over years, facts that change over longer time scales, but now we are seeing facts that are changing every week. Like my imagination of what is possible to be discovered is changing every week because yet another person comes up with a new idea that they can do with large language model. with generative, and that is also creating this explosive rate of content being created, experiments being designed and done, papers being published, people having opinions, people trying interesting products. What's your opinion about all this from that book's point of view, like things that you were talking
Yeah.
about there? Is it What can we learn from what you said in that book about how should we handle this amount of information that is being thrown at us that is changing every week almost?
Yeah, so that is a very good question, and I think there's not an easy answer of like how do we handle all this. And I would say one of the things in writing that book, and it's been a number of years now, so I'm only gonna half remember some of this, but like the and we are supremely adaptable as humans. Like we are very good at adapting. Like we went very quickly from like the iPhone of like, oh my god, this is an object dropped from the future and it's so amazing, to like, why doesn't it do X, Y, or Z, and just like complaining about it. Like we forget like how amazing this thing is. And so I imagine we will pretty quickly go to from like, oh my god, this is overwhelming, to like, why doesn't it do the following things, or how can I just is another piece of technology. So I think we're very adaptable. Now in terms of the how do we use these technologies themselves, and kind of like how do we kind of think about this like massive amount of information, and just like new ways of thinking about this. And I think it offers a huge amount of opportunities. And so in terms of like stitching together different pieces of knowledge, I mean, for the longest time, and like when people try to build these systems in terms of like thinking about like the ones that can kind of like either generate novel hypotheses or kind of connect different papers, one of the hardest things is like trying to actually extract that knowledge from the scientific literature, and like creating sort of rigorous ontologies or whatever. And these things break very, very easily. But now with large language models, we don't have to worry. There's a lot more kind of like slack and fuzziness in the system. And so, and actually, one of the things you mentioned about like this web of knowledge and interconnection, like right, we each of us have a web of knowledge in our minds, and there's kind of the web of knowledge that is known maybe by a field, but there's an even larger web of knowledge of things that actually should be connected, but maybe we don't even realize. And so for example, I was kind of playing with this, I guess maybe was it last year, 2 years ago. I can't remember. Things are moving so quickly. Again, I've lost track of time. So, but I was playing with GPT-3 in terms of having it use having it generate alternate histories. And so this is going back to like science fiction. This is actually one strand of science fiction that I find very interesting. It's kind of like the what if of like, what if some tiny bit of history were were a little bit different, like someone were assassinated, or an assassination didn't happen, or some tiny war, or some tiny aspect of a war happened differently, or there was an outcome, or someone was never born, or whatever it is. And then kind of seeing what are the ramifications there. And so I asked GPT-3. I kind of basically gave it like a whole bunch of like summaries of other alternate histories that I found on Wikipedia, and said, okay, I want things in this style. And of course, I now ChatGPT and GPT-4, like I have not gone back and tried these things again, but I imagine it's going to be like orders of magnitude better. But I basically said, okay, like I don't know, what if like Jimmy Carter were reelected president in 1980 as opposed to losing reelection against Ronald Reagan, or I gave a number of different things. And for me, I mean, the scenarios that it kind of spun out were kind of bonkers and not so great. And like there was one scenario that I got from an alternate history that, and basically, it was clearly cribbing from like Star Wars, because it started talking about the Galactic Empire and some like weird thing. But at the same time, though, for me, the most powerful result of all these was the fact that it gave me insight into the factors that I should be thinking about. Kind of like basically going back to that web of knowledge, like, okay, here are the following like suite of factors, geopolitically, socially, the different things that I should be thinking about if that thing were different in history. And I think, and so like there's other tools, like Elicit is another one of these tools that is very powerful for kind of helping people survey the literature, but also helping people think rigorously, break down a problem, or kind of use LLMs to kind of think about, okay, what are the different factors that I should be thinking about when I'm working on this specific research project or research tool. And I think, and so going back to what you're saying, like I think LLMs are incredibly powerful for kind of helping augment our own research, but it's kind of like research and imagination, which is often when we do research, it needs to be very rigorous. And when we think of imagination, it's kind of just like, oh, it's all over. We're thinking about different things. But the truth is, the best research is a sort of rigorous imagination, which is, okay, when I'm doing this, let's think about the space of possible hypotheses that I should be thinking about, or the space of possible ideas that I should be connecting together. And in many ways, LLMs are incredibly good at that, and especially in they hallucinate. I mean, and many people view hallucination as a bug. I kind of view it as a feature in terms of that sort of like early ideation. And actually, and going back to like the early days of computing, and this is actually one, and like hallucination and or like brainstorming, like these things are actually not new things that computers can do. Like if you go back to like you look in like computer magazines from like I don't know the 80s and 90s, they're all talking about like a digital napkin where you can like sketch out your ideas and connect different ideas together. And actually, I believe the ideas of Don Swanson, who I mentioned, this information scientist, I think he actually ended up creating a brainstorming tool related to some of the ideas he used decades ago. And so, but now we have the ability to kind of take these things that people wanted to do decades ago and now overclock them with the kind of like strapping on LLMs on top of these kinds of things. So I actually think there's a really interesting way of both like under like kind of taking new knowledge and kind of putting it into the web of knowledge as well as using it for kind of this like human machine partnership when it comes to kind of creative knowledge.
100%. I was given a talk last week in a workshop that we ran on large language models on the topic of knowledge ops, which in my mind is this continuation of DevOps into ML ops into knowledge ops. Sort of like DevOps allowed us to create automation augmentation around software development. Model ops extended that thought process and set of tools to systems that included data and models. And now with generative capabilities, we are getting to an age and time where we can automate and augment our ability to imagine and plan, which is a very knowledge intensive activity, but we are operationalizing that so that we can design experiments faster, we can carry them out faster, and we can discover faster. So one of the points that I talked about, and I see listening to a critical piece was missing, was that I sort of said, in order for a tool to be able to think, to help us think, it needs to have language skills, it needs to have logic skills, and it needs to have memory. So it needs to be able to remember all of the things that we don't or we don't want to remember. It needs to be able to talk to us, understand what we are saying and talk back to us with the results. And it needs to be to do logic through some task that we're trying to solve. And remarkably, language models are fantastic at language skills. Like, they completely have solved that problem. But the other two, well, mostly have solved that problem. But the other two pieces, the reasoning and memory, they also are very good at interfacing with other types of data structures and logical systems and calculators and simulators and all of those things. Like, they're becoming very good at using tools. So that opens up a whole new area of interesting things that can happen. But I think what I missed, and now listening to you go back to it, is the factor of creativity is also a fantastic thing that they're introducing. So if this hallucination, the first time that I heard a lot of our art is drug induced, I was like, wait, what? And that's exactly what you're describing. There is a factor that is creating hallucination, which is generally talked about as a bug, but it could be a feature if it is controlled and integrated into the right user experiences into the systems. So this whole new era of generative powered human computer interface is very interesting to see where it goes. But from what I see, and I'm sure you're seeing a lot of startups pitching to you with all of these crazy ideas, one of the most major problems is, what is the user experience for this kind of new way of human computer interface? Because it is not like anything that we have seen, and it has so much potential. But what are some of the ways that this can actually help us effectively think and discover and build?
Yeah, there's a lot there. This is super interesting. I mean, and one of the things, and you mentioned in terms like this is like a new type of interface and a new way of thinking. And I still think like we're still figuring out like what are kind of like the right interfaces. And I think and like one of the things when I saw kind of like the jump from like GPT-3 to ChatGPT, Like on the one hand, like you're like, oh, it's like, I mean, it's a little bit more powerful. It's basically the same thing. But the truth is, it wasn't the same thing. It went from being this kind of like API plus kind of coding playground to just a chat interface. And I think the ease with which people could play with it just unleashed all these different ideas that people had. And so it was one of these things where I quickly realized, oh, like, no, like the specific interface, the specific way in which we can kind of interact really makes a big difference. And you can see this with like a number of other tools that kind of allow you to kind of create this like feedback where you interact with some sort of generative AI. It gives output, then you connect it to some other things, then you kind of feed it back in. And I think what you were saying initially of like that these tools are basically the glue that kind of, it's like this fuzzy glue that allows you to connect lots of other different things that up until this point have not been able to be connected, I think is really, really important. And the truth is actually going back to like the history of computers and programming languages, people always talk about this idea of like composability or this idea that you can kind of connect different pieces together. And LLMs allow that in a very, very powerful way. And I think in terms of what you're talking about, like the specific interface and like this like HCI component, like that kind of composability of that LLMs allow is something that we're still in the very early stages of understanding. And to be honest, it's going to be amazing to see what people kind of stitch together and how they do this kind of thing. And it's not going to be the kind of thing of like, oh, it's not either or. Of like it's not either GPT-4 can do everything or it's not worth it. It's not like it can do some stuff, but then, okay, maybe it breaks down on really big numerical equations. That's fine. We have really good tools for that. Like you connect some LLM to like Mathematica, or you connect it to some other like just a calculator, like that's fine. And then you can connect it to some other database. Like it doesn't like and so the fact that we don't have to kind of make these compromises anymore. We can kind of say, okay, these things can be connected. And when we want to have the more open-endedness for the creativity, yeah, don't connect it. Allow that kind of hallucination to go wild and like just kind of see what kinds of things are created. But I think there is this, but going back to kind of both the glue and the kind of open-endedness for creativity, it creates a sense of like you can say, okay, here's my ideas, give me some new things, and then you kind of go and like you iterate and you say, okay, maybe the stuff that it gave me is not so great, but then you take the output and modify it, then put it back in. I think there's going to be this increasing sense that we can kind of think in partnership with these systems, both at the kind of like construct, kind of like dealing with knowledge, kind of like the kind of like glue aspect, as well as the creative aspect of the kind of like the ideation aspect. And that's something that I think we're still trying to figure out. I think it's going to take a while to figure it out. Right now, I mean, we're kind of like been given these amazingly powerful tools, and we just like don't know what to do with them yet. And I think someone was telling me this of like kind of in the early days of like movies and television, they didn't really know what to do, so they just kind of like recorded plays, and then they realized, wait a second, like once we have a camera, you can do all these different kinds of things. You can have like quick cuts, you can have different shots that are close up, you can do all these different things that were not available when you were just looking at a play or a musical, like in a theater. And I feel like a lot of and I think the analogy this person was saying was like that in many ways, the early stages of LLMs are kind of like that, where it's like, oh, like search is really good, and like we kind of know about search, so let's like just kind of like strap search onto an LLM, and like you get kind of like some sort of like like Bing chat interface or whatever, and like maybe that'll do well, and maybe it'll be interesting, but it's going to take us a little while to figure out, okay, what are the true unique abilities and affordances of these generative systems, and then create something totally new. So I think we're still kind of in that like theater on television screen. Yeah, so but yeah, so I'm pretty sure my friend was like spot on in terms of that way of thinking.
That's a very interesting analogy. Um, I really want to double click there. Sam, you hinted at this in your past answer a bit already, but you mentioned that a lot of the work and thinking you do is the ripple effects of new tech. And so, what are the most, maybe some of the more exciting ripple effects that you suspect, even if you don't have a strong evidence for it yet, but your gut feel is that we can expect from these LLMs coming forward?
Oh, that's a really good question. I mean, to be honest, I feel like I'm not like I can make predictions and like, but I'm not always that great of predictions. And so for me, actually, I can maybe get to some predictions and some ideas and how to think about that. But first, I would say one of the more interesting things that I think about is kind of like at the societal level in terms of like I've been watching a lot about how like how people respond and to these new technologies. And so for me, it's like the LLMs and like ChatGPT in particular, like when it kind of was unveiled several months ago, at the time of this recording, was for most people it felt so qualitatively different that it created this like almost like weird reckoning where people were almost reduced to kind of like a more primitive version of themselves in terms of how they responded, where it was like people saw this and like immediately jumped to like awe and almost like religious worship, or like this like unbelievable like fear. And it was like super. And so for me, and I'm not, and to be honest, I know we should be excited by these kinds of things. I don't necessarily think, and we should be cautious, but I'm not sure the massive extremes are the right responses. I kind of feel that like a mixture of both like caution and wonder and excitement are probably a much more healthy sort of response. That being said, the fact that these technologies are so qualitatively different, at least in how people perceive them, even though obviously they're in this kind of like clear lineage of many things, that for me was just very interesting to see. And I kind of want to, so for me, I'm just like, in terms of prediction, I don't have a prediction, but it's more just like, I am paying a lot of attention to how people are responding rather than, and in addition to kind of the just technologies themselves. But I would say in terms of if I had to make a prediction, I do think that these tools are going to unleash a very different, like a very exciting and different manner of creativity. So like going back to like this creativity thing. So like if you look at like, so like when DALL-E came out, and I was like one of the early users, and there was a certain period where like all of Twitter was just nothing but people like sharing their prompts and just like weird pictures. And it was great. It was a lot of fun. It was like people did this a lot, and then there was kind of like there was like the initial like burst of excitement, and then most people are like, okay, now I'm going to kind of use these as a tool, or I'm going to begin thinking more deliberately about prompt engineering and kind of think about that. And I feel like a lot of the like ChatGPT stuff was the same kind of thing. Where like first it was more just like playing with it and kind of get a sense of okay, what is the space of possibilities, and then there was kind of the like more boring period of okay, now let's try to iterate and kind of figure out how these things are useful. And I think but I think in both those cases, it's though there's kind of the burst of excitement, then kind of like the more boring period of just kind of like getting into the weeds and figuring things out. But I think in both cases, it's going to be followed by another period of unbelievable like blossoming and flowering of a whole bunch of new things that people do not realize. What those are going to be, and again, I have no idea. But I'm very excited for it. But I think it's going to be kind of like burst of excitement, not quite trough of despair, but like kind of like burst of excitement, trough of quiet tinkering, followed by burst of oh my god, this is how we should actually be playing with these kinds of things, as opposed to just the original era of just kind of like playing with them, like and like in sort of like the theater kind of version. But so I would say that's a very hand wavy, high level kind of way of thinking about something.
Yeah, I'm very excited to see how we'll go from cute science fairy type of projects people are doing to projects that actually make a difference in what we invent. It's funny that you talked about how people reacted when ChatGPT came out, and it reminded me of a guest that I was inviting to the show, and I was on a coordination call with them, and they were like, "We should definitely talk about how this system seems conscious." And I was like, so maybe topic for another day. But yeah, definitely people had a very interesting range of reactions to that whole thing. And I'm excited to see that hype dies down and the real projects that will come out of it.
Yeah,
Uh,
actually, just one thing I would add. I think an interesting thing is to like look to how like kids view these kinds of things. So like so I have two young kids, and like I like when I got access to Dolly, I had them like sit next to me, and like they would come up with prompts, and like and they were really good at breaking in things. But like for them, it was like magical and exciting. But because I think they didn't have a sense of like what they thought should be possible and not possible, there was no kind of preconceived notion of like, oh yeah, this is like super weird and insane. And more like this is just a fun thing that I'm going to play with. And I feel like the same kind of thing with like ChatGPT. It's like I think look, and obviously there's like a downside of like if you don't have any preconceived notions, then you might kind of like take these things for granted, and you might not like delve more deeply or kind of think about questions around explainability, which I mean, little kids are not thinking about at all, and like that can be left to the adults and the experts. But I do think sometimes like the stance in which they kind of perceive these might actually be not necessarily the most worthwhile one, but certainly a worthwhile one because they're not like they're certainly not at like the extremes of how to think about these things. They're just like this is another fun thing that I want to play with, and I think yeah, we can definitely learn something from that.
Yeah, for sure. They last night we've been building our product for about 4 years now, and last night was the very first time that I felt the machine was really collaborating with me to think through a problem.
Mm-hmm.
So I was in a meeting with my R&D team, and they threw out a bunch of ideas, and they were like, could we use this, could we use that? And as I was walking, uh, some inspiration occurred to me, but I wasn't really sure what to do with it. So in the fashion of eating our own dog food, I started talking to our product, saying, is this too crazy? And the way our product works is that it's a very curious chatbot that just asks you a lot of questions and helps you think through things. Within 20 minutes, I downloaded a notebook from our product that was several pages long, summarized all of the things we talked about, and proposed a way to actually implement it. That I immediately sent it to my R&D team, and I said, what do you think? And immediately sent that to three reinforcement learning experts that I know from our community, and I said, if we were to implement this, what are the nuances? So it is creating a whole different mode of communication. I can just brainstorm with myself with this cheating approach, and then immediately create an artifact that is ready for negotiation with my internal team, with experts I know, with a stakeholder that I'm working with. So definitely a very, very exciting future is coming up, and I'm excited to see where it goes. Last thing that I want to touch on before we start wrapping up is this phrase that you used when we were doing the coordination call: programmable serendipity machine.
Yeah.
And you said you said sometimes sophisticated AI is not necessary. Just some AI stuff, human brain and randomness can create a lot of interesting things. So can you expand on that a bit? What
Yeah.
are you thinking when you say
Yeah,
something like
no,
that?
no, yeah, this is great. Yeah, and so for me, I mean, I mean, just professionally, but also personally, I'm very interested in kind of like ways of like promoting serendipity, of kind of like these like unexpected connections between different ideas, because it'll help me with my writing, or it'll help me with my research, or connecting different people. And I've for a long time kind of tried to figure out, okay, how can I build little tools for myself to kind of do this kind of thing. Um, so, for example, I have a lot of books. I often get them with like for a certain reason, and then I kind of put them on the shelf and don't revisit them as often as I could. Um, but then I realized if I just if I just sent myself an email of like 5 randomly chosen books from my library, and kind of said maybe these are 5 books that you might want to reconsider. Um, that might be enough to kind of spur me to kind of think about some things in a different way. And so kind of the way I kind of view it is, yes, like these LLMs are great for kind of stitching together ideas or kind of helping with ideation or brainstorming, and uh, and like these are great, but I don't think it's like an either or kind of thing of like, okay, now we only have to use these. The truth is, when you give yourself a certain kind of like set of random prompts, whether it's books or ideas you haven't thought about in a while, or just like here's a note that you wrote for yourself 2 years ago, and now you're obviously your brain is different now. That might be enough to kind of shock your current brain pattern into a new mode, kind of like the whole like simulated annealing thing of like, okay, you kind of gotten comfortable here, like now let's move over to this other area. And so for me, and the truth is, and these generative AI systems are very, very sophisticated, but the truth is, I mean, the human mind is also very good at stitching together ideas and knowledge, and often finding and and sometimes to its detriment, like finding connections maybe when connections are not necessarily there. But at the same time, though, it might find connections that you initially hadn't thought of because you're now being introduced to new things. And so for me, I love building these kind of like very simple tools that are like brain dead relative to these generative AI and LLM systems, because all they're doing is just kind of giving me some like a snippet of random things and emailing it to myself or whatever. But like that is enough to kind of realize, like to kind of leverage the combinatorial power of the human mind itself without having to use all this complicated AI. So for me, I mean, the sophisticated AI techniques that we have, I mean, we are in very early days and they are incredibly powerful. But I still think at the same time, it's not either or. It's not like we either use that or we have nothing, or maybe not even either or. It's like, it's not this is the only path. It's like we can kind of use this in combination, or sometimes even just instead we just use these kind of simple tools. And so for me, I still think, yeah, there's power to be had in kind of these like very simple serendipity tools that combine randomness with this kind of like the power of the human mind.
Yeah, 100%. Ironically, the specific idea that I mentioned I had last night is very, very related to this. So we are working on this idea of interactive reasoning where machine does a bit of reasoning, but also delegates a bit of reasoning to the operator, to the human that is interacting with it.
Oh,
So
great.
they essentially collaborate through the steps of reasoning, and essentially our own machine helped me think through that. So that's definitely a very, very exciting future.
Yeah.
I want to see where it goes, but I want to
Me
wrap
too.
up here. I want to start wrapping up. So, Amar, what are you going to think about differently after this conversation? And Sam, what's your verdict for people who have been listening to us for the past, almost an hour? What should they think about differently? And what's your take-home message for them?
Hmm. I'll go first. The way Sam talked about the ripple effects of tech and really kind of putting things together with LLMs in almost a Lego-esque fashion. It was already on my radar, but the way he articulated it, like some very simple systems and mushing them together in an LLM, that really drove that point home. I want to think more on that. Yeah. If I have some cool stuff, I'll shoot you some ideas and some demos I come up with, Sam. Yeah.
Oh, thank you. No, I'm glad that that resonated. Yeah, I would say for me, I mean, yeah, and certainly kind of this gluing aspect is interesting, but I also think, like, yeah, I guess like the major kind of like take home message is for me just kind of like thinking about this kind of like human machine partnership, in terms of like how we create and how we think about creativity. Obviously, creativity is this very kind of open ended but also combinatorial process, and as we generate more and more knowledge, it becomes harder for humans to kind of do that combinatorial process unassisted. And so the fact that we have these tools should not be like, we shouldn't view that as, oh, like this is a limitation of the human mind. Like the human mind is already limited. There's only so many things we can hold in our minds. Like this now allows us to avoid stagnation when it comes to certain aspects of creativity. So for me, I'm actually very excited about that.
Beautiful.
Fantastic. For me, one area that we didn't touch on, and you know, uh, and I'm generally very excited about, is also an unexpected outcome of what we've been working on for me, is the fact that these kind of interfaces, these kind of capabilities are also affecting human machine interfaces, right? So essentially, the ability of playing the mediator between humans as they're trying to communicate with each other. Like in the example that I gave, I was not able to tell my R&D team what I was thinking, but machine enabled me to communicate that. And I think once we expand that to a multiplayer scenario where a lot of humans are trying to think through the problems, when we expand it all the way to citizen science, into network science, there could be a lot of fascinating things happening when we combine crowd intelligence, these kind of interfaces that we have, and create these very complex intellectual networks that is bringing back some of Sam's background on complex systems into these interfaces that we are creating. So I'm excited to see where it goes. As I think I said 5 times already. But thank you so much for being with us, Sam and Amar. This was a fun conversation. And thanks, audience, for listening to us. Hope to see you next week for another episode of Deep Random Talks.
So
Thank you.
All right.